So more on comparables, right? Which we'll be going over in more detail, right? So again, comparable, right? Has this? It's an interface with a single function, and it's for anything that can be put in any kind of order. So if I do a string s is equal to, so let's go ahead and create a string over here. String s is equal to hello. We'll see that there's actually that we can use the compare to method. Actually, I'm just going to do it in main so I can call it s dot compare to goodbye. And let's print out the result we get from that. So, first question. What's the mechanics for putting things in order when it comes to... what are mechanics for putting things in order for strings?
Alphabetical as well as like capitalization.
Yeah,
right?
alphabetically. And caring about... And yeah, we would care about capitalization. So, so that's the way it compares that. Let's go ahead and take a look at comparing numbers. So integer, so let's go ahead and create integer I is equal to 5. I dot compare to, so it's an object. That's why I can use the compare to method. Another integer, so let's look at 17. And maybe, and we're going to experiment and find out what this ends up being. This isn't where I intended going with it, but it's useful to know because we will be doing with comparables later. So we get -1. Okay, that's interesting. We get -1. What if I compare it to this number? Still going to get -1 for the compare to. What if I do 4? So 5 dot compare to 4 produces 1. And 5 dot compared to 5 gives
0.
Us, So the documentation for comparable says basically you have full control over the integer you return, but there's basically 3 rules. So if you will do a, so we have a dot compared to b. So let's go ahead and make it so that we can talk in more abstract terms. So it's all comparable always has the format of a dot compare to b, or some variation thereof, right? And it says essentially if a is less than b, then we want you to return a negative number. Okay? So when you do compare to and use a is less than b, we need you to, like in this case, then it should return a negative number. What negative number should it be? I don't know. Let's look at... It doesn't really matter. It's just got to be negative. So less than also means comes before. So let's go and say apple is alphabetically before goodbye. So let's go ahead and run that. So notice it came up with -6. Any guesses as to why it says -6 there?
I'm going to take a wild guess and say number of letters.
Yeah, that's my guess too. It probably has something to do with the distance between the alphabetical distance between A and G. I mean, if we do apple and aardvark, it gets a bit more complicated, unfortunately. That a laser I see? Yep. So it gets a bit more complicated with letters like that. I'm sure there's a whole formula in the documentation for it. It's not really important. What's important is that because apple comes after aardvark alphabetically, it's bigger, so to speak, then it's a positive number. If the two numbers are equal, or the two things we're comparing are equal, or have the same value, then we return 0. Oh, yeah, it's a clip. And finally, If A is greater than B or comes after B, then you return a positive number. Now, why do we care about comparable? Well, if things are comparable, then they can be sorted. Okay? So if you can compare two things, then you can sort two things. Sorry, if you can compare things, you can sort things. If you can't compare them, you can't sort them because then there's no ordering. So one of the solutions that some people come up with, which is actually an incomplete solution, but I give credit for it anyway because it's using your noggins, is that you can use the collections.sort class for this, and because this is the most elegant solution I've seen for this. Although the disadvantage is that it only works on E's that are comparable. And that's what you're saying over here with this. You're saying we're taking in a list of stuff and another list of stuff, and all the things in the list are comparable to everything else in the list. That's what this means. E is comparable. What are they comparable to? Other E's. So this is the most elegant solution I've seen for this one. Sort A, sort B. That sorts them in place, by the way. All right. And now we can ask, are these two things the same list? Now, because if they're permutations of each other, if you sort them, they'll come out to be exactly the same. Make sense?
Yep.
However, again, what if we were checking if two things are permutations but they're not comparable?
What's an example of something that's not comparable?
Objects.
Okay.
Objects are not comparable. Lists are not comparable. You can't A dot compare to. There's no compare to method because you can't tell how if one list is should come before another list if you have a list of lists, right?
Mm.
Yeah, it gets kind of crazy like that. A server object wouldn't necessarily be comparable, so there's all sorts of things. So here's the thing: if we remove the requirement for these things to be comparable, which you should, you can't sort them because we don't know how to sort them. So let's go ahead and do this with with basically as best we can. So first, let's go ahead and check the sizes. If these two sizes are not equal to each other, and again, for those of you who haven't seen it before, this is just my font being awesome and making the not equal into one big not equal. Okay. Return false. Now again, we're going to assume true. Okay, so if A and B are different sizes, then they can't be permutations of each other. That is a belt. A belt. For each E item in A. One second, and I'll tell you. That is... I'm not sure what that is.
Put it on.
I don't think it's meant to go on. It looks like a... It looks like a suspender again, so or something. Okay. For item in list A, what we're going to do is we're going to count the number of times it appears in A and count the number of times it appears in B. We've been working too much in Python. Keep forgetting I have to declare variables. And add semicolons. Okay, count A, count B. So we're going to count the number of times it appears in A, count the number of times it appears in B. So for each E, A, item A in A...
Just so you know, your video is kind of laggy. It's not it's only updating like every second or so.
Oh, interesting.
Yeah, because he's not optimizing video for screen sharing, which I think is fine.
Do I need to do that? I didn't realize I had to... Hold on. Is that something I can do? Stop. Share. Laser. What's up?
I think
Optimize.
Rolo's
There
right.
we go. Cool. Better now?
Oh yeah, that's a lot better.
All right.
Oh, but it's very low resolution.
Is it? Can you read it?
Yeah, we can't read that anymore.
Oh, so
I
much.
think it's Wi-Fi speed, maybe.
I mean, I'm on my I'm on a gigabit connection here, so I guess I'll just share screen and then you have to deal with the lag.
I think it's fine.
It's not like I'm doing too much of anything. So, for every item, if a dot equals item,
It's actually a lot better now for whatever reason.
a, and now we do the same for b. And now we count the number of times that item appears in b. So notice that I have a loop that basically I have two versions of the same loop for every item in A, for every item in A. That's what I mean by saying it's messy for this problem. So for each item in A, we count the number of times it appears in A, then count the number of times it appears in B. If count A not equal to count B, and I'm not a monster, so I'll put spaces in between that.
So just to clarify, when you say for each E item, E is the generic,
Type.
right?
Yeah, it's the type that is in the list, right?
Awesome.
For E item, meaning for, so you have to put the type of whatever kind of thing you're iterating in over here for some reason, because you're declaring a new variable.
So you could even put like int if necessary.
If it was a list of integers,
Okay, cool. Thank you.
then you could do that. But since we don't know what it is, we have to use E. I mean, I think I could do object over here, but it might. Yeah, we could do object over there because object can be anything. So. And so now, so there's our code. It's a bit long. Basically, if they're different sizes, then we know they're not permutations. Otherwise, set up the number of times for that item, set up the number of times it counts it. You count it in A, count in B. Count the number of times it appears in A. Count the number of times it appears in B. If those are different, return false, because then they aren't permutations. You get different counts. Otherwise, if we make our way all the way through this, all the items, then we can return true. So that's how you do that one. Any questions about anything that I've gone over with this regards to this problem?
For some reason, when I do like not equal, like that they're not equal to each other, so like both the first and last if statement, I get an error, and I don't know if it's like, I don't know why I get an error.
Are you doing question mark? Are you doing the exclamation point equals?
No.
That's what you should do. My
Oh.
not equal sign is done. So what I've got is a feature in my IDE that supports font ligatures. So, if I go to fonts over here, I've selected a specific font called Fira Code. And I keep it nice and high resolution because because I want to make sure you guys can read it. And then I have font ligature checked. If I uncheck it, you'll see that it goes back. And font ligatures are a feature on many fonts, but this one just simply exploits it for coding terminology. Here, let me go ahead and show you an more example of font ligatures.
If
So-
you're showing us a
I did it on the other screen and pulled it over, so you guys can see it now, right?
Yep.
Okay. Widely used TH together. Let's see. So here we go. This is a very common one in text. FI like this, and FL like that. So you'll see that. Yep. So then here's some stylistic ones. And these are letters on the side. So so fonts support a lot of fonts support doing this. Right? A lot of fonts do, computer typesetting. And then, what this does is it uses what it refers to as programming ligatures to make it, to create those symbols. So here, divide equals looks like that, and then and this is less than hyphen hyphen, or rather, this is less than hyphen to get this. This is less than hyphen hyphen. This one is less than hyphen. And then equal signs over there to get those. Maybe it's 2. Not sure. But what's nice is that basically it's just taking advantage of features that already exist to make the code easier to read. Although some people like it and some people don't. It says Microsoft Word does not enable ligatures automatically. So it's just one of those.
Prof, not completely, well, almost completely unrelated. Do you know how to pronounce Elon Musk's child's name?
I have no idea. I don't know who Elon Musk's kid is.
Well, no, but like they tried to put like mathematical symbols into his name, and California was like, no.
Mm-hmm. Yeah, names are weird. Names are really, really weird. Assumptions programmers make about names is one of my favorite articles. Falsehoods programmers make believe about names. People have exactly one full name, one full name with to go by. They have, at this point in time, exactly one full canonical name. People's names do not change, but they change only at certain events. They can be written in ASCII. People's names are not written in all caps. People's names have an order to them. First names and last names are by necessity different. People's names are globally unique, almost globally unique. My system will never have to deal with names from China or Japan or Korea. Or any of these, which all have a weird naming scheme in common use. That Klingon Empire thing was a joke, right? So, anyway, names are complicated. Okay. Any other questions? By the way, if you want to get that code, that font that I'm using, it's automatically installed in IntelliJ. But if you want, that's how I got exposed to it. It was produced by, it's based off of Firefox's font library, which I'm a big fan of, or Mozilla's font library. And you can get, if you want to download it for other programs, you can get it here on the GitHub repo. Yes, Laser. And this is just what it looks like with the ligatures versus without the ligatures. What was that? I can't hear you. Your mouth is stuffed.
With what?
What is your mouth stuffed with?
Crackers.
Is it crackers? Wow. I'm jealous.
You want me to get you some crackers?
No, I'm good.